Here's the lecture for 4.1 and 4.2, Evidence of a Chemical Reaction and Chemical Equations. So we're going to start with a little warm-up, which is a review from the previous unit, so I would recommend pausing and filling in the answers before you move on. I can only hope you actually pause, so here we go. KOH, if you know, OH is our polyatomic. How can you figure out if it's a polyatomic? Well, we kind of went over them, and they are also on the back of your reference sheet. They are in this upper corner. So, K is potassium. OH is hydroxide. So the name for this formula is potassium hydroxide. Looking at the second one, HgO. Hg is mercury. Mercury is a transition metal, so we gotta include Roman numerals to look at the charges. If I'm looking at this compound, they're 1 to 1, so this is an invisible 1, and so I have Hg plus 1 and O minus 1, but oxygen, we do know the charge, and it's supposed to be minus 2, so we multiply both by 2, which means the name of this should be mercury 2 oxide. So oxygen as an anion will become oxide. NO2, you see 2 capital letters. N is nitrogen, O is oxygen. This is a covalent compound, so we will be using prefixes that tell us how many there are. Nitrogen, there is only 1, but we wouldn't say mononitrogen because it's the first one. 2 is di, and so this would be dioxide. So nitrogen dioxide. Some of you might have thought nitrite, the polyatomic, but again, polyatomics are going to have these charges. So if we're looking over here at nitrite, it would have been NO2 with this minus button. But we are not talking about ions, we are talking about actual compounds. Well, formulas. Write the formulas for the following names. Ammonium dichromate. Ammonium is one of our polyatomics that is a cation, has a charge of +1. Dichromate is Cr2O7, and it has a charge of -2. This is where we would have to do the crisscross method because they are not 1 to 1, and you'd get NH4 with the 2 on the outside, and then Cr2O7. You could put dichromate in parentheses or not. It doesn't matter because it's just one of them. But for your ammonium, you do need it in parentheses because this is saying I have 2 ammonium. Chromium 3 oxide. This is type 2 because we have Roman numerals. The 3 belongs to chromium. Chromium symbol is Cr. We know the charge is +3 because it's in the name. Oxide, there's our friend oxygen again. And so now we just do the crisscross method. Cr2O3. And then silicon dioxide, we see di, so that's a prefix. So it's a covalent compound. Silicon, there's no prefix, so there's just 1. So it's Si. Dioxide, we know that's 2 oxygen. Great job. If you're having trouble, I really suggest going over your notes from Unit 3. Now, we're finally in equations, so we're entering a new unit. It's Unit 4. 4.1, evidence for a chemical reaction, and you're going to learn the signals that show a chemical reaction has occurred. Here are some things that help us remember how a chemical change has happened. So recall that chemical changes have an unexpected color change. Heat is produced or absorbed. A solid forms, which is called a precipitate. If we're getting really lazy and trying to note it during our labs, you can write PPT. And bubbles form, which is gas. And that's all of 4.1. 4.2, chemical equations. You're going to learn to identify the characteristics of a chemical reaction and the information given by the chemical equation itself. So, what information can we get by looking at a chemical equation? Well, you can see that there's reactants on one side and products on the other. You notice that there's an arrow in between that separates them, and then you see these plus signs that you've probably seen in your math classes. If we wanted to name these, CH4 is methane, oxygen is O2, CO2, hopefully you know, is carbon dioxide, and H2O is water. If you wanted to be fancy, you could say dihydrogen monoxide, but we don't have to be fancy. So when you're reading these chemical equations, you could say methane and, right? So These are just symbols that represent words. And O2 produce CO2 and H2O. You could also say CH4 reacts with O2 to form CO2 and H2O. You could say CH4 combines with oxygen to yield CO2 and H2O. Some other things you could probably say would be like CH4 and O2 produce CO2 and water as like a byproduct. So sometimes you'll see the word byproduct. But the reactants are on the left side of the arrow, and I will highlight them in this like pinky color, I guess. So these are your reactants. You can have multiple reactants. You could have one reactant. Sometimes if you just have one reactant, the word to use would be like decomposes. If you have one. And then you have your products on the other side, which I will put in blue. Sometimes you can have one product. Sometimes you can have multiple products. It's okay. It doesn't always have to be equal, the amount of reactants and products. But you do have to make sure that whatever elements are on one side do need to pop up on the other. Also, a word could be synthesizes. So these could synthesize together to form something else. But those are some ways that you can read a chemical equation. Now, what was missing from that example, though? States of matter. We talked about states of matter in the beginning of the year. There was 3 of them, but in this case, we are going to talk about a 4th state of matter as well. So, solid is abbreviated with a lowercase s, liquid, lowercase l, gas, lowercase g, and then we have something that's aqueous. So, to be aqueous, sometimes we could say like dissolved. Whoa, I did not spell that right at all. Dissolved in water. That doesn't mean that one of the products is water. It's just telling us the state of matter. Like if I was like carbon, solid, liquid, water, gaseous, carbon dioxide. I could say blah, 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 dissolved in water. That would be aqueous. Usually if you see an acid, that will also be aqueous. Or if the compound has a polyatomic, at least in our case, it's probably most likely some sort of aqueous solution. Now, I'm going to give you all these wonderful descriptions, and we got to figure out how to write them into chemical equations. I like to color code things. You don't have to, but here are the colors I'm going to be using. So I'm going to be using red for my reactants, and I'm going to be using blue for my products. I like to circle the compounds or elements, and I like to underline the words that help me realize if they're reacting together, if it's decomposing, or if it's a product. So I'm going to go back to my red color. You got solid potassium reacts with water. Perfect. Potassium reacts with water. So I'm going to write that out really quick. Potassium, and it's a solid. These are written like subscripts. So just like those little numbers in formulas, the parentheses lowercase s, the states of matter, are usually also subscripts. Water. The fact that it doesn't give me the state of matter, we could probably believe water is gas. I'm going to switch over because I see the words to form. So I'm going to draw my arrow. What's being formed? Hydrogen, gas, and potassium hydroxide dissolved in water, right? Here's our wonderful dissolved in water. That doesn't mean water is a product. That's telling me that this is going to be aqueous. So to form hydrogen gas plus potassium hydroxide. And it's aqueous, so AQ. I'm like almost there. I just need to actually turn these into formulas now. So potassium, that's just K plus water, which is H2O. And we know these. Hydrogen. Hydrogen is special. Hydrogen is something that we call a diatomic, which means out in the real world, when you're looking at elements by themselves, hydrogen is going to be coming in pairs. And there's 7 of them. If you look at the back of your reference sheet, right in the middle, you have diatomic elements: hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, and bromine. If you were looking at the periodic table, let me highlight these for you. They make a 7, almost, right? You have NOF, and you have chlorine, bromine, iodine. Notice there's only 6 of them. Don't forget your wonderful hydrogen on this side. So those are your diatomics. Switching back over, and you got potassium hydroxide. Let's finish this equation. That was one of the warm-up questions. And so that's AQ. Some of y'all have been writing AG, and it's not. It's AQ. If you wanted to box this, that's super awesome. If you want to be super extra and highlight them in your notes because you're like, this is my equation, go ahead. But that's our chemical equation. Let's look at another one. Solid mercury 2 oxide decomposes to produce liquid mercury and gaseous oxygen. Well, looking at my reactants, something's decomposing, and it's mercury 2 oxide. Decomposing. So I'm going to write mercury 2 oxide decomposing. So I only have one thing. It's producing mercury and oxygen, gaseous oxygen. So I have mercury, it's a liquid, plus my oxygen, which is gaseous. Next step is to turn them into formulas. So mercury 2 oxide is HgO, and it's a solid. Decomposing, so I only got one reactant, and I have mercury, which is just going to be Hg, and it's a liquid, plus oxygen, which is a diatomic. And there we have it. Solid mercury 2 oxide decomposing to produce liquid mercury and gaseous oxygen. Let's look at another example. Solid carbon reacts with oxygen to form gaseous carbon dioxide. Let me switch my colors again. Carbon reacts with oxygen. I'm going to write that down. Carbon, it's a solid, reacts with oxygen. In this case, it's probably a gas. I'm going to switch colors because something's being formed. It's my product. Gaseous carbon dioxide. So carbon dioxide, and it's a gas. Next step is to turn these into their actual formulas. Carbon is just C. Oxygen is O2 because it's a diatomic. Switch colors to my products. Carbon dioxide is going to be CO2, and it's a gas. Box this, highlight it, whatever makes your soul happy. But that's our answer. Next example, you have, let me switch over to my reactant color. You have solid magnesium metal reacts with liquid water to form solid magnesium hydroxide and hydrogen gas. Before I switch colors, I'm just going to write this down. Magnesium metal, so it's solid, reacts with water. It says liquid. Switching over to form, what's being formed? Solid magnesium hydroxide and hydrogen gas. So I'm going to write magnesium hydroxide. And it says a solid, so I'm not going to assume it's aqueous. And hydrogen gas. Got to turn these all into compounds. Magnesium is just Mg plus our water, which is, which is H2O. Magnesium hydroxide, Mg, has a charge of +2. Hydroxide is OH, it's -1. Let me put my polyatomic in parentheses. If I switch these, right, swap and drop or crisscross, you have Mg, OH2, and it's a solid. Plus hydrogen, which is our diatomic, it's a gas. And then here's our chemical equation, right? Solid magnesium metal reacts with liquid water to form solid magnesium hydroxide and hydrogen gas. Here's another one. Solid ammonium dichromate. Ooh, it's decomposing. So solid ammonium dichromate decomposes. So we know that we have one reactant to what? To solid chromium 3 oxide with gaseous nitrogen and gaseous water as byproducts. So look at that. We have 3 products and we only have one reactant. So we have ammonium dichromate, and it's a solid. It's decomposing to chromium 3 oxide with, so that's plus nitrogen, it's gas, and water. It's also a gas as your byproducts. So now we actually have to turn these into compounds. So if we're looking at ammonium dichromate, that was one of our warm-up problems. So we have NH4, put those in parentheses, and then Cr2O7, and that's a solid. Switching colors to chromium 3 oxide, which is Cr2O3, chromium oxide, which was a solid. Oops, so I'm going to put the solid there, plus nitrogen, which is a diatomic, so it's N2, and water we know is H2O, and it's also gaseous. So there we have it. This is our chemical equation for that. And that's the last practice problem. So have fun doing the homework. Send me an email if you're confused, but there it is.